This is another video about UnitSystems.jl. I normally like to do a lot of computer programming and working on different projects, and this is one of the projects I made. I don't normally, always talk about it, recording like a video about it. I do a lot more projects. I publish a lot more code and projects on open source than I make videos about. So like I'm constantly doing work on open source projects and programming things, and not always making a video about everything that I do. But I'll just today I'll take a look at this 5-year-old project of mine. So I started this about 5 years ago, UnitSystems.jl. And so it's on GitHub. And yeah, let's take a look at I have this as a PDF document. So there's a website. So there's a GitHub repository. And I've got this website, units.crucialflow.com. And it's still up. So units.crucialflow.com seems pretty straightforward, I think. So yeah, so it has a website, and if you go on the menu, you can see that there's a lot of information here. If you click on any of these are all categories like constants, and each one of these is a web page, and the appendix contains lots of additional information here. And this information has also been compiled into a PDF document that's 706 pages long. And so it consists of 3 packages, actually. So you could do using UnitSystems, or similitude, or measure systems. And if you're just interested in exploring the concepts involved, then I recommend using measure systems, which deals with uncertainty values. So it can propagate the uncertainty in a value, but that's using another Julia package called measurements.jl. But I don't recommend using measure systems with measurements with these like these measurements uncertainties. I don't necessarily recommend using that in all applications. So that's why there's 3 different packages available depending on how simple you want the calculations to be. Do you just want floating point numbers, or do you want like a sophisticated uncertainty calculation in your units? So yeah, those are different options you can take when you decide to load the package. Which of the options do you want to load? All right, so let's take a look at the PDF document. In 2019, the SI 2019 standardization was completed. Okay, so this is called UnitSystems.jl and the Unified System of Quantities, USQ. So in 2019, there was the SI 2019 standardization, which was completed, and it was based on the 7 physics dimensions specific to the metric system. And what I found is that is actually an inadequate and insufficient unit system standard, as it is mathematically impossible to unify all historical units with this standard. So in 2020, myself, Michael Reed, set out to work around that impossibility with a new project called UnitSystems.jl, which ended up completely solving this problem with a brand new 11-dimensional unified system of quantities for physics. So that's this project, UnitSystems.jl. That's what I started in 2020 and what it was. So in aggregate, the unit system data that's generated constitutes a new universal standardization for dimensional analysis, which generalizes upon previous historical systems up to the 2019 redefinition and unifies them in a common universe. This enables a more precise and generalized standardization than the 2019 redefinition, which was comparatively limited in scope. Newly specified unit system values are available as a newly defined mutually recommended standard, verified to be consistent and coherent. A unit system can only be useful as a measuring standard if it can be scientifically reproduced, so the data here has been standardized. So basically, what that means is this is a standardization, kind of like the SI 2019 was a standardization that allows people to reproduce similar kinds of data. So this is something like that as well. So if you if you follow the same data standards that I presented here, then you're adopting my standard basically. So you're kind of adopting the standard that I set out. So I'm kind of like the NIST, the National Institute of Standards or something. What I've presented is kind of like a standards organization type of thing. And I'm the one who created it. This paper includes the UnitSystems.jl appendix information, which has been documented on my website since 2020, and a new preface with my audience reaction to Wolfram's recent plagiarism of this project, including a timeline of events leading to the plagiarism. So this is something new which has recently come to my attention. I don't have time to completely, dig into all the things going on that they're doing there, but I'll give you the timeline here. So in the timeline of UnitSystems.jl registration and the Wolfram research plagiarism. So in 2019, the SI 2019 standard is formalized with a primitive SI only unit system based on the 7 physics dimensions. And this was a massive collaboration. So in 2020, I started registering UnitSystems.jl. And I discussed with Ted Korkovilos about what the unsolved and nuanced issues are with defining physics units, because I was I was registering this unit systems package, and so Ted could download it and we could talk about it. And I've gone through several releases while talking to him. And so we were talking about the unsolved and nuanced issues with defining physics units, and I then solved it by independently creating the never before seen 11-dimensional unified system of quantities for physics. So unified system of quantities, this is a name that I came up with because there was already an international system of quantities. So I figured if I was going to make a new standard with a different name, I would replace international with unified. So this is the Unified System of Quantities for physics, which was standardized in detail and completely handcrafted by myself alone in this project, basically, where I was also talking to Ted Korkovilos, who was involved with trying it out and giving feedback and talking about it and things like that. So then in 2021, there was Wolfram Research who invited me to their summer school, where everyone was hinting at the fact that I would be hired there. So they were saying that things like that. So the Wolfram Research interviewed and then hired me with an explicit interest in my UnitSystems.jl work from the lead developers. So they were like very specifically interested in this project, this UnitSystems.jl project that I had. They requested that I present them my independently discovered UnitSystems.jl results in the Wolfram language to make a comparison with their existing system. So while I was shortly an employee at Wolfram, I indeed directly handed them my newly discovered Unified System of Quantities. And when I did that, my work was already independently complete and prepared, ready to incorporate into their stack. So all I had to do was give them a presentation on it, and that's what I did. So they acknowledged that their system was old and outdated compared to mine, as they only implemented a metric and imperial unit system, and neither of these was up to the standard of my UnitSystems.jl standard. However, they told me that I would not be allowed to work on this project further because they didn't want to upgrade their systems. Instead, they did the software equivalent of placing me in kind of a backroom shed to mop the floors. So this is not literal, this is just kind of like... After 6 months, they ended the contract, and it turned out that they lied to me on the job application about what my role would be. Because they said all these things about how... But this all kind of seemed misleading when the job actually started. It wasn't like that, as it was kind of... as I thought, or as I don't know. Yeah, so but then that was the end of that. So then it was so then there was a few years in between where Wolfram keeps inviting me to their winter and summer schools to help mentor people, but I declined because I was too busy making progress in my research, and because they already were making it clear that they don't want to actually support my work in a way like that. I wasn't sure why it would make sense to go mentor anybody there, because yeah, I don't know, they even told me that I was like a competitor while I was a mentor at the summer school the year before, or previously, and they said to me that I'm their competitor or something, and there was a lot of different things going on, so no point in going to all this detail, but let's just keep it going. And then let's go to right now. So now we have 2025, and so now Wolfram bribes this Memes of Destruction, which is the name of a social media thing, at Wolfram Summer School to take my fully prepared work. So I previously gave them the fully prepared work that I presented to them, and they use it to boost the Wolfram brand on social media, presenting my complete project. And it appears to me like they probably use AI generated text based on what I understand about Wolfram, and without crediting that I was the person who handed them the completed project years earlier, before you add all the text around it or whatever else they did, or incorporated it into Wolfram Alpha or whatever it seems that they did there. So yeah, I directly handed them that, and if you the Wolfram, I had Wolfram language code published on GitHub and things like that, and I gave them the presentation using the Wolfram language. So yeah, here's an example of like a Wolfram notebook that I presented them, which had the fully functional historical unit system, all the same information I have in Julia that they can already try out in the Wolfram language. This was many years ago already, so I already fully solved this problem many years ago. They could already have taken it from me years ago when I was working at their company for a short time, when they lied to me in their job application. And they asked me about this project back then. So yeah, that was the notebook for that, Wolfram notebook. So I was wondering, did Wolfram think that they can pluck these low-hanging fruits from my garden to build their brand on social media? My only goal here is to show that these low-hanging fruit that Wolfram plucked, these fruit came from my public garden and they were not grown or developed by them from scratch. It was my solo project that I presented to them. And so the academic institutions, I think they should be directly investing in my research instead of funding and enabling Wolfram research to systematically gang stalk me with an army of employees. So I can feel the presence of these Wolfram employees looking over my shoulder and monitoring my every step. They're constantly like using, whenever I do something, they do something. It's like it's like this army of people mimicking everything I'm doing, but they don't want to acknowledge my existence. They're just like, I don't know, these weird people who constantly want to copy everything I'm doing, but pretend like it's, I don't know, it's really weird. The way they do it, at least, it's a weird way they go about doing it, like a gang stalking type of technique or something. And there seems to be an entire economy of people being paid to monitor and surveil me while I struggle to survive with my resources. Stephen Wolfram never seemed to care about earning my respect. Every time I interacted with him, he was only focused on talking about himself, and that was basically the only topic. And so it's kind of like what you would imagine talking with Stephen Wolfram would be. It's him just talking about himself, basically, as far as what I've collected, what the information I've gathered, or what I've experienced firsthand or whatever. It's fascinating to me how unaware Stephen Wolfram is of the fact that people perceive him as a kind of textbook specimen of ultra narcissism. And this isn't just something that I'm just saying randomly. Like, this is, if anybody knows anything about Stephen Wolfram, I think they would probably come to the similar conclusions. This is because he is entirely surrounded by people who are these yes men with a salary, depending on how much they inflate the Wolfram ego, basically, which completely divorces these people from the reality of doing actual scientific research. Because they're not, I don't know, let's not get into it. It's a lot. You can unpack that if you want. Wolfram's premise seems to be that they can use gang stalking to target open source developers like me to data mine our work, enabled by funding granted from academic institutions who don't check for Wolfram's plagiarism violations. So basically, there's all these academic institutions that are funding Wolfram because they have a subscription to his software. And technically, these academic institutions have standards about plagiarism, but they're just buying these subscriptions from Wolfram and not necessarily doing a rigorous audit about what kind of plagiarism Wolfram is doing. So yeah, combining the ultra narcissism of Wolfram with the economic incentive to target open source developers with gang stalking by an army of employees, it becomes highly uncomfortable knowing that these people are incentivized to gang stalk me for the rest of my life with smear campaigns and so on. So I'm urging the academic institution to quit enabling and sponsoring Stephen Wolfram's systematic gang stalking of individuals like me. He shouldn't be rewarded for plucking the fruit from my public gardens, which I handcrafted. Wolfram does not acknowledge that my science research is what's boosting their brand in the social media campaign that he's funding, which is memes of destruction. So we'll go into that in the next page. Yeah, so these are things that this is like something that I worked on, like this unified system of quantities. And they, I don't know if they don't understand that they're like stealing that they're like doing plagiarism by not acknowledging that this is like, that I handed them this project. Well, we'll see. We'll get into it. I don't know. Let's just, the only point really is to show that I did this project and I handed it to them, and they're pretending like I had nothing to do with it, like I don't exist or something, right? So like it was their idea or something, but I was the one who did it independently, and now they want to act like somehow that they came up with these things, even though it's my standard that I allowed them to get a presentation of it. So Julia Computing, they are no better stewards. They are also unethical people, but at least their product is open source and therefore a solid foundation. My work on the UnitSystems.jl and the entire process of creating the new 11-dimensional Unified System of Quantities, USQ, that was all entirely done in public on GitHub, and each release registered with several scientific websites. This is only one of my side projects. The mainstream of my research is my differential geometric algebra software development, Grassmann.jl and Cartan.jl, and various related work at the cutting edge of science, making me a bigger target for Wolfram's gang stalking. Because they're also interested in all these other projects that I'm doing. They're like stalking everything they can find about me, like very systematically. They don't want to talk to me about like, hey, can we like hire you to bring some of these ideas to our company? No, that's not how they approach it. They like gang stalk me with all these employees, and then they invite me to their summer schools, and then they want to gang stalk me at their summer school, like surround me with all these Wolfram employees who are all going to stalk me there, basically. It's like this giant stalking operation. And they don't want to actually acknowledge that they don't actually want me to actually do anything on their team. They just want to stalk me, basically. They just want to surround me and stalk me, but they don't actually want me to actually participate in a way where I'm like, where they're like, we're like working together to take the ideas so I can bring them to build something, you know what I mean? They just want to like stalk me and then claim credit for it or whatever. That's what it seems like. That's what the experience is like for me. So it appears that Wolfram tends to resort to plagiarism of other people's works by data mining other people's creativity through employment, ghostwriters, summer schools, shady business practices, and some kind of identity theft and bribes, basically. So the bribes is because he was like funding these social media campaigns or paying people in whatever ways to implement this gang stalking operation of open source developers, right? The incentive behind this systematic gang stalking appears to be this. Instead of working with me directly, they all wish to kind of ostracize and isolate and erase me. And this is not just limited to Wolfram. This seems to span several communities, but it all started happening around the time that Wolfram was reaching out to me. So it's like as if like when the Wolframs started to get involved with me, I started to get being ostracized and isolated from everywhere. And except for the Wolframs, they were like the only ones. Like it was as if like everywhere was like pushing me away, and the only place I could go was Wolframs. The eventual goal is then replacing me and then retroactively claiming credit for my past achievements to boost their brands. Yeah, so that's what it seems to be. Well, that's what seems to have already happened, right? So I presented them this project, and then they retroactively claim credit for it, even though this is like publicly an achievement of mine in the past already. Ironically, the temptation to incorrectly eat the fruit of my labor like this will be their downfall, as this choice is accompanied by the firm evidence of plagiarism. And plagiarism is considered a violation of the academic standards by the academic institutions that are funding Wolfram research. And so I guess my projects are effectively ego traps, which will trigger the downfall of the ultra narcissist ego if it's incorrectly consumed. And that's what happened, I guess. So because I didn't think this would actually happen, but it actually happened now. And so now they retroactively, it feels like they're retroactively claiming credit for my achievement. That's what it looks like. So I know the academic institutions don't acknowledge me either. So all I can do is to permanently add the Wolfram plagiarism disclaimer to the original sources. So I'll just add this additional statement, just a general statement about having a quick 0 to 60 speed and pathological lying. That is not necessarily a sign of the high intelligence and long-term thinking, because you're just quickly coming up with lies pathologically. So it's not in a good way that constructs a good long-term foundation. Rather, it's an indicator of a complete lack of long-term thinking, demonstrating an optimization toward the short-term illusions of success, which then falls apart upon any scrutiny. If Wolfram does not want to be perceived as the confirmed plagiarist, then Wolfram must acknowledge that I'm the creator of the new Unified System of Quantities, which he's using. He's like using my standard that I presented them, and they adopted it, but they don't want to acknowledge that they adopted my standard, which is the underlying foundation for the completed research project I handed them. And they like padded it with AI generated text. So they adopted my standard that I standardized, and then they just like presented it like as if it's some kind of project they came up with, even though I publicly standardized this and handed this to them. So yeah, where were we? So yeah, I'm the original creator of the Unified System of Quantities, and we're gonna study that in a moment, which is the underlying foundation for the completed research project I handed them. And they seem to like pad it with some kind of AI generated text or whatever it is. So Wolfram is well known for the claims that LLMs will replace writing of code and text. So we're going to assume that the foundations of their work rests on the AI generated text on top of my presented complete project foundation. And the LLMs and the AI models, they all know about my UnitSystems.jl work. They were all like the LLMs, like this project goes back to 2020. The LLMs were already trained on my project. And it was pretty good training data for the LLMs. And therefore, so mine was the only reference work in existence which had completely implemented this unified system of quantities, right? That was my standard. So I'm the original reference for it. And the LLMs, they were trained on my reference information, my original reference that I created and started creating in 2020. And therefore, if you're using the AI or the LLM to generate text to manipulate my unique project, then if Wolfram is doing this project with an LLM, it's been trained on my, like, I'm the source data that the LLM was trained on for this unified system of quantities, right? So so if he's so if they're using this AI generated text to fill out all these paragraphs in their project, and that's been trained using around the skeleton of the project that I had, you know. So it's just like regurgitating my original project using AI and LLMs they were already trained on my data, right? Kind of like those, you know, when you're talking about image generation and they were trained on other people's artwork. So where were we? So this is effectively transforming the original source data, which was ingested from my work, using my own knowledge embedded in the LLMs. Wolfram is regurgitating the fruits of my labor without acknowledging that I directly handed this to them as a completed project. Like, I literally presented this to them as a complete project that if they wanted to, at the time, they could have worked with me to fully implement this in the Wolfram language, like to propagate it to the rest of their systems, right? Because I already had this all ready to go. So then Memes of Destruction, the social media campaign, self-proclaims to not be an expert on the topic and publicly discloses the paid sponsorship from Wolfram for the social media campaign. So we can count that as transparency from that perspective. So yeah, this is my audience reaction to the Wolfram plagiarism situation. So yeah, I figured, so this wasn't really meant for necessarily for YouTube, for like as a script for YouTube. So I figured I'd present this here as well. And we're gonna read the actual rest of the paper now. This was just kind of the foreword. This was the preface from 2025, the reaction. The UnitSystems.jl appendix has been documented on our website and registered as a Julia package since 2020. The core unit system standard was last updated in 2022, and similitude and measure systems have received some minor design updates. So the unified system of quantities. In aggregate, the unit system data that was generated here constitutes a new universal standardization for dimensional analysis, which generalizes upon previous historical systems up to the 2019 redefinition and unifies them in a common universe. This enables a more precise and generalized standardization than the 2019 redefinition, which was comparatively limited in scope. Newly specified default unit system values are available as a newly defined mutually compatible recommended standard, verified to be consistent and coherent. A unit system can only be useful as a measuring standard if it can be scientifically reproduced, so the data here has been standardized. In fact, there's nothing transcendental about dimensions. The ultimate principle is precisely expressible in Newton's terminology as one of similitude, exact or approximate, to be tested by the rule that mere change in the magnitudes of the ordered scheme of units of measurement that is employed must not affect sensibly the forms of the equations that are adequate expressions of the underlying relations of the problem. And this is a JL quote from 1914. And this is I actually tried to figure out what JL's full name was, but I could never find out what the full name was for JL. So this was just this paragraph in like a newspaper clipping, or not a newspaper, like a journal or whatever. And it was just referenced as JL, and I never figured out who JL was. So if anybody can figure out who the JL was who said this in 1914, I'd be interested to know who it was. So the specifications for dimensional units are in the UnitSystems.jl and the similitude.jl and the measuresystems.jl repositories. The three packages are designed so that they can be interchanged with compatibility. On its own, UnitSystems is the fastest package, while similitude provides the quantity type, and measuresystems introduces the measurements.jl uncertainty. And so these are kind of like constructively building additional features on top of the UnitSystems base definitions. So you have this kind of selections of 3 different packages that you could pick from. So there's an optional environment variable for similitude, so that it returns true or false depending on what you set this as. So it's just a convenience function. It's not really important for beginner users, but it's just left in there for documentation purposes. We'll just skip that. So the unit system definition is basically this type right here, and it contains these 11 fundamental constants of physics. A unit system is a consistent set of dimensional values which is selected to accommodate a particular use case or standardization. It is possible to convert derived physical quantities from any unit system specification into any other using accurate values. 11 fundamental constants are used to govern a specific unit system consistent scaling. These are the constants Boltzmann, Planck reduced, light speed, vacuum permeability, electron mass, molar mass, luminous efficacy, angle, rationalization, Lorentz, and gravity. Different choices of the natural units or physical measurements result in a variety of unit systems for many purposes and applications. Historically, the older electromagnetic unit systems also had a rationalization constant and a Lorentz force proportionality constant. In most unit systems, these extra constants have a value of 1 unless otherwise specified. So basically, you set these fundamental constants with certain values, and that creates a unit system definition. And that's the fundamental idea. That's why it's called UnitSystems.jl, because it's about constructing a unit systems through the selection of these 11 fundamental constants. And so I've had the documentation website here, units.crucialflow.com. There's several pages and stuff. So the derived dimensions can be obtained from the multiplicative base of 11 fundamental dimension symbols F, M, L, T, Q, theta, N, J, A, R, C, corresponding to force, mass, length, time, charge, temperature, molar amount, luminous flux, angle, demagnetizing factor, and a non-standard one that doesn't really have a name. A specification of the unit system is in dimensions of entropy, angular momentum, speed, permeability, mass, molar mass, luminous efficacy, angle, rationalization, Lorentz, gravity force, and values that are interpreted by units. These are like values that are interpreted by the units. And then we have these dimensionless coupling values which specify the universe. So the specification of the universe with the dimensionless coupling constants, coupling, the fine structure, so this is like the gravitational coupling, fine structure constant, the electron unit and the proton unit, and the proton-electron ratio, and the dark energy density. This is not something I really use, but it's included here just for because a lot of other scientists are interested in it. Alterations to these values can be facilitated and quantified using parametric polymorphism. Due to the coupling interoperability, the measurement systems package therefore makes it possible to support calculations with measurements having error standard deviations. So the Unified System of Quantities. So what is it? So in order to kind of start talking about what it is, we have to build up to it. So in the base unit systems package, there's just the float 64s that are used to generate the group of the unit system constants. However, in the similitude package, there's more like symbols and a group algebra that's used to generate an abstract multiplicative group, which is only converted to a 64 float value where it's appropriate, like when printing out the result. In unit systems and similitude, the spectrum of constant values is generated by a group of 11 mathematical constants, 7 integer primes, and 2 irrational numbers, with 33 measurement definitions. So these are all listed here. So the primes are basically 2, 3, 5, 7, 11, 19, and 43. And there's a reason why all of these are present. Basically, they're part of the definition of various ratios involving, multiples of 60, for example, like 60 seconds and things like that. So that's why these prime numbers show up here. And it turns out that this finite set of prime numbers is sufficient for the goals in this research paper that I gave. So in this research paper, it's enough to just have those finite primes that I'm talking about. And then we have phi, the golden ratio, and gamma, the Euler-Mascheroni constant, and E, the exponential constant, and tau, the 2 times pi. And the golden ratio and the Euler-Mascheroni constant are actually optional for the unit system definitions, where we are including them here because of the Julia language. We'll get into that in a moment. And then here's the rest of the 33 physical measurements. So, for example, the length of a foot was defined exactly in terms of meters. So there's like a bunch of these measurements that can be used as building blocks for our unit systems. So this is kind of like building blocks. Like you have a bunch of building blocks that you can stick together to build something, right? So all the numbers that we're going to build in my unified system of quantities that I proposed can be expressed with all these building blocks. So these are the building blocks. And some of these could have an uncertain value, like the Rydberg constant. It's known very precisely, but or the fine structure constant could have some uncertainty in what the exact value of it is. So that's a measurement value, right? So we don't know what so that's why we're going to give it a symbol here, because it could have uncertainty, and the source of the uncertainty comes from trying to measure this value. And so we're going to capture this measurement in this symbol like that. And so we can kind of abstract the notion of uncertainty by abstracting the measurement as this symbol here. And we have this finitely generated set of measurements. Since Julia already exports a pi symbol as an irrational type, tau is used as the exported group element. So the Julia language already has pi. So since I'm building my own algebra, I figured instead of trying to overwrite pi, I can use tau instead. And so that's simply a matter of convenience to use tau as an available symbol for the group when pi is already something in the Julia language by default, and I don't want to interfere directly with what pi is doing in the Julia language. So that's why I'm using tau. So it's not an ideological statement about whether tau is better than 2 pi. That's not what this is about. It's just because I did this in the Julia language, and it made sense to kind of do it like that. All right. Inclusion of the golden ratio and the Euler's gamma Mascheroni constant is unnecessary and not required for any unit system. And they are only included as a bonus because, again, the Julia language offers 4 irrational numbers by default. And so just because it's there already, we might as well include them in our specification. But if you're using a different programming language, you don't have to make that same choice. Furthermore, in similitude, there's a dimension type which encodes the dimensional group for the quantity type. So this enables the unified usage of the group homomorphism to transform quantity algebra elements with varying numbers of dimensionless constants. Originally, the Newtonian group used for the unit system was derived from the force, mass, length, and time, or FMLT. So those should be familiar to people who study physics. Although force is typically thought of as a derived dimension, when the reference gravity is taken to be dimensionless, force actually must be considered a base dimension in general engineering unit system foundations. With further development of electricity and magnetism came an interest for an additional dimension called charge, or Q. When the thermodynamics of entropy became further developed, the temperature, or theta, was introduced as another dimension. In the chemistry field, it became desirable to introduce another dimension of molar amount, or N, as fundamental. To complete the existing international system of quantities, it is also necessary to consider luminous flux, or J, as a visual perception related dimension. In order to resolve ambiguity with solid angle unit conversion, angle, or A, is tracked in the underlying dimension, group algebra dimension. However, this is yet insufficient to fully specify all the historical variations of unit system, including the EMU, ESU, Gauss, and Lorentz-Heaviside specification. Therefore, there is also a dimension basis for rationalization, denoted by R, and Lorentz, denoted by C inverse. So the C dimension is actually the inverse of this. In combination, all these required base dimensions definitions are fully necessary in order to coherently implement all unit conversions for quantity elements. Since the existing international system of quantities is an insufficient definition for this, a new unified system of quantities is being proposed here, as composed of force, mass, length, time, charge, temperature, molar amount, luminous flux, angle, rationalization, and a non-standard dimension denoted by all of these are denoted by FMLT, Q, theta, NJ, AR, and C. So this is the unified system of quantities. These are 11 dimensions, while international system of quantities dealt with less. So I define a quantity in terms of a choice of unit system and a number and a dimension. So quantity U is like the type and has the values V and dimension D. And the syntax, this just shows you the syntax, right? If you're interested in studying the programming language syntax, so like you take a unit system and plug in a number and a dimension. That's how this works. So we take metric, 1 energy produces a joule. So so energy is like a dimension. And so if you take, you know, metric 1 energy, that's a 1 joule. An alternate syntax, quantity U, V, number D, is also available as standard syntax. When using unit systems instead of using similitude, this syntax can be written so that code doesn't need to be changed while the output is generated with either package choice. So that, again, there's just some flexibility about which package of the 3 that you want to pick. So the convert unit type is a constant for unit conversion of the group elements from U to S. So if we have 2 unit systems, U and S, then this is the unit conversion. So like energy metric CGS produces a convert unit. Yeah, so the application of the unit of these is of course for unit conversion. So this tells you how you can convert ergs to joules from the metric to the Gauss system with 10 to the 7 basically. And or convert energy from the metric to the English system. And converting a quantity to another unit system is enabled as a function call. So any quantity is a function returning its value in any unit system. So if you have a quantity, it can be treated like a function where you can plug in a unit system. So my quantity U. For example, to convert 1 joule from the metric to the English, you can do it like this. You take metric 1 energy and you convert it to English. The new Unified System of Quantities proposed here is a convenient way of specifying unit system definitions. As proposed by Planck, both a person and his proposed unit system, specification of the dimensionless Boltzmann, Planck reduced, and light speed is of immense interest in the syntactic grammar of unit system definitions. In fact, it turns out that these are the natural unit of entropy, angular momentum, and speed induced by the unit system. For electromagnetism, there have been several proposed base definitions for extension. Recently, with the SI 2019 redefinition, it was proposed that elementary charge is to be taken as a base definition for electromagnetic units. Now, this is a mistake, as elementary charge is actually not the natural unit of charge induced by the unit system, therefore making it unsuitable as a fundamental constant for any unit system. Yet vacuum permeability exactly corresponds to the natural unit of permeability induced by the unit system, making it suitable as base definition for electromagnetic units. So what this means is this is just in the SI 2019 they tried to use elementary charge to define what a unit system is, but that's actually not possible because a unit system is defined in terms of natural units. At least in my formalism, a unit system has to be defined in terms of natural units, and elementary charge just simply isn't a natural unit. And so what SI 2019 does is it doesn't actually define a proper unit system. So it's not a proper unit system according to the standards that I've set out. So my standards are more strict than SI 2019, and the strictness of my standards it means that SI 2019 is incomplete. It's not the correct way to approach it. Now, that doesn't mean it's wrong. It just means how they define it, like the terminology. It's not aligned. The terminology is not advanced enough, is what I'm saying. The vocabulary they use is not complete enough. They don't have a complete enough vocabulary to express this. So, when you have the complete vocabulary to express this like I do, then you can understand that vacuum permeability is actually a natural unit, and because it's a natural unit, it's appropriate to use it as a foundational definition for unit systems. Much simpler to understand is that the electron mass is the natural unit of mass induced by the unit system. So that's not very controversial. Molecular chemistry units are further defined by the natural unit of molar mass induced by the unit system physics. Specification of luminous efficacy is a natural unit of human perception induced by the unit system. The altered angle scaling is defined by the natural unit of radian induced by the unit system. Additionally, for the Gauss and Lorentz-Heaviside electromagnetic unit system definitions, there is an induced natural unit of rationalization and a non-standard unit named Lorentz. Finally, the gravity force specifies the reference natural unit of gravity induced by the unit system. Therefore, for the sake of natural units, instead of defining unit system in terms of the USQ dimensions, the following are used. So we don't use like force, mass, length, and time and things like that. What we do use is we use the Boltzmann constant, the Planck reduced, the light speed, the vacuum permeability, the electron mass, the molar mass, the luminous efficacy, the angle, the rationalization, the Lorentz, the gravity force. Or this is what I use. I don't know about we, but this is the standard that I created. So in my standard, there's 11 of these, and these are the ones I pick. Like when I created this definition, I picked these 11 ones. Like you could perhaps make a different choice, but this is the appropriate choice that makes the most sense because these are all natural units, and they're natural units of entropy, angular momentum, speed, permeability, mass, molar mass, luminous efficacy, angle, rationalization, and the non-standard one that we can't really name. The isomorphism between newly defined unit system of quantities and these 11 fundamental constants is used for the new unit system definition, and this is what connects the base dimensions with the fundamental natural units. And we'll get into that later more, what that means. By default, this package provides a modern unified redefinition of various historical unit systems which were previously incompatible. In order to make each unit system consistently compatible with each other, a few convenience assumptions are made. Specifically, it is assumed that all default modern unit systems must share a common universe of dimensionless constants, which can be modified optionally. The fundamental philosophy is to fully characterize nuances among unit system instances by means of dimensional constants. As a result, all the defaults are ideal modern variants of these historical unit systems based on a common underlying universe, which are completely consistent and compatible with each other. These default unit system values are to be taken as a newly defined mutually compatible recommended standard, verified to be consistent and coherent. In the Système International des Unités, the SI units, the unit system constants are derived from available accurate physical measurements and a few exactly defined constants. Exact values are the Avogadro number, Boltzmann constant, Planck constant, light speed definition, and also the elementary charge definition. So what we've got is these 5 numbers right here that we're going to start out with. So that's like the Avogadro number, the Boltzmann, Planck, light speed. So in SI 2019, these are pretty standard. Physical measurement values with uncertainty are the electron to proton mass ratio, the mu EU proton to atomic mass ratio, the inverted fine structure constant, and the Rydberg constant, and the Planck mass. So that's more building blocks. So these are these building blocks that we talked about before. So we're just starting to list some of them that are some of the most important ones. And this one is already composite. So if you take a look at the electron mass, it's already expressed in terms of several things. Additional reference values include the ground state hyperfine structure transition frequency of cesium-133, delta nu CS, and luminous efficacy of monochromatic radiation, KCD, of 540 terahertz. So these are further fundamental constant definitions that are foundational building blocks. As a result, there are variants based on the original molar mass constant and Gaussian permeability, along with the 2019 redefined exact values. The main difference between the two is determined by mu and mu0 offset. So basically, you can construct a metric system by selecting these constants, and particularly mu and mu0 are the key ingredients, and the rest is fairly standard. Construction of the unit system instances based on and this is actually my own procedure here, so this is my own custom procedure I arrived at. You take these ingredients and produce these constants from that. This is there are many ways you can combine these constants, but to produce different kinds of formulas, but there's a particular reason why these are the inputs and these are the outputs, and it's because this is the metric system constructor, and it makes sense to abstract it in this way. But we're not going to get too caught up in why I'm abstracted these things in particular ways. So this construction of the unit system is based on constants, and it helps characterize the difference between several derived unit systems. So when you plug in different things here, it produces similar unit systems, but you can tweak them by just tweaking one of these numbers, and then it becomes, these are measurements, right? So if we have a different measurement for the Rydberg constant or the fine structure constant, we can update the unit system by putting at this point, like this is the function where we plug in those numbers that what the measurement is. So this constructs a new unit system from molar mass constant and so on. So the standard metric system has the exact molar mass and exact vacuum permeability that was familiar for a long time for many people. And then in SI 2019, there was an approximate molar mass and an approximate vacuum permeability choice made. And both of these are possible in my system. So my unified system of quantities is so general that it allows you to simultaneously have both of these. And the point is that one is the metric system and the other is the SI 2019 system. And the difference is that the original metric system had kind of exact molar mass and vacuum permeability, while the SI 2019 compromises the exactness of those values by making them approximate, and instead other values become exact. So it's a trade-off. And the engineering system has a kilogram and the kilopond, kilogram force units. So the metric system is constructed here with the exact values, and the SI 2019 system is with approximate measurements. And then the engineering system has the gravity reference here. The metric variants, they can include angle scaling, and that's why there's all these variants like metric turn, metric degree or arc second. It's just that it's just to demonstrate that you can change the angle if you want. So it's just an example and standardization of it. The conventional system constructor then builds on the metric system. Other derived unit system instances, such as the British or the English or the IAU, are derived from existing metric specifications generated by the metric system constructor here that I'm talking about. The constructor metric system incorporates several standard common numerical values and exposes variable arguments which can be substituted for customization, yielding the capability to generate historical variations having a common universe. Derivative constructors are the entropy system, electric system, Gauss system, Rankine system, and astronomical system. Historically, the Josephson and Klitzing constants have been used to define the conventional based on 1990 and co-data based on 2014 variants. So this is a little bit simpler. In 1990, they took these measurements of this Klitzing constant and the Josephson constant, and then then we can also pick the molar mass constant and the molar gas constant and the Planck constant and the speed of light and so on. And if you take these, then we can construct a vacuum, permeability and the Boltzmann constant and the electron mass and so on. And that's how these systems were constructed in 1990 or in 2014. So this constructs the new unit system from von Klitzing constant and the Josephson constant with an optional universal gas constant and gravity reference. And originally, the historical practical units were specified by the resistance and electric potential with electrical calibration equipment. So if you specify this resistance and voltage, you can modify the 7 or the 11 or whatever the number of constants by multiply by rescaling them according to this voltage and resistance. And this constructs a newly derived electrical unit system from U with mass rescaled by an electric potential and resistance. In the international system, this Omega International and Voltage International are used as definitions from the more recent United States results, while an international mean and earlier estimate of the other nations was used. So this was like a really big research topic of mine. Nobody had ever, there was no information in modern times about this. I had to go back to the way original sources from many decades, a long time ago, to get this information and figure out how to fit it into this modern unified system of quantities. It took a lot of research to figure out how exactly to do it correctly. And then once I figured it out, it turned out to be fairly simple to do. But the original leap of understanding to even understand what the problem or I don't know. It took a lot of research to figure out that this even exists, this historical unit system, and that this is how it's defined and how to fit it into my modern system. It just took a lot of work, you know. And this was all done by me. I'm the one who, nobody else, like there was no modern research on it. I was the first person in modern times to revive this, like this international like many of these things, like the SI 2019, they abandoned everything that came before it, right? Anytime they made a new one of these unit systems, they kind of abandoned everything else, right? Because they said, oh, we're gonna now, it's now 1990, we're gonna define things like this now. Or it's 2014 and we're gonna define things like this now. It's 2019 and we're gonna forget everything and we're gonna define things like this now. My system doesn't do that, right? So my system can allow all these different choices to exist simultaneously, and you can convert between them. So the electromagnetic CGS systems, alternative to the SI unit system, are the centimeter gram second variants, where the constants are rescaled with centi times meter and milli kilogram units, along with introduction of additional rationalization and Lorentz. So the electromagnetic CGS system, they were constructed like that. There are multiple choices, such as electromagnetic units, electrostatic units, Gaussian non-rationalized units, and Lorentz-Heaviside rationalized units. This Gauss system constructs a new unit system from U, rescaled for CGS with electromagnetic options. The first three options are set the values for vacuum permeability, rationalization, and Lorentz constant. And the next two parameters are the scaling for the length and the mass, while the last is to change the gravity reference. And so the EMU system can be constructed with that, and the ESU system, so you can specify these constants in a particular way, and that either produces the EMU, the ESU, or the Gauss, or the Lorentz-Heaviside system, right? And they're derived from the metric system. So you input the metric system, and then it modifies it according to this scheme that I came up with here. So this is all my original research. These unit system definitions, nobody has ever tried something like this before. I'm the first person to try to explain how you can express the EMU and the ESU system in terms of constructing it in this procedure. And the exact procedure is actually in the source code of the computer program, right? This is just a PDF document where I'm revealing some of the details in paragraph and equation form, but the actual construction, of course, is in the source code of the computer program, right? And I had already handed all this to Wolfram, right, when I was... It's already been public, like I've been working on this for a long time, since 2020, so... the modified entropy unit system. So the other unit systems are derived from the construction above by rescaling time, length, mass, temperature, and gravity, resulting in a modified entropy. So this is another kind of classification of... So I'm like so the entropy modification is basically in terms of time, length, mass, temperature, and gravity, and that's how it works. So it's another one of these constructors where you specify time, length, mass, rescaling. Constructs a new unit system from U, rescaled along time, length, mass, and temperature by the first four parameters. More optional parameters allow for customization of the vacuum permeability, molar mass, and gravity. So the gravitational system and the nautical system, meters, tons, seconds. Examples of this type include the nautical, meridian, gravitational, MTS, KKH, MPH, IAU, IAUE, IAUJ, Hubble, cosmological, cosmological quantum. Most other constructors for unit system derivations are based on internally calling entropy system, such as astronomical system, electric system, Gauss system, and Rankine system. So all those other constructors, they're in specialization of this one, entropy system. This means that entropy system also constructs the examples listed for those constructors. So yeah. In Britain and the United States, an English system of engineering units was commonly used, with this temperature rescaling of 5/9 for Rankine, for the modified entropy. So this is just a modified entropy system, but a particular choice of temperature rescaling. So that's called Rankine system. Constructs the new unit system from U, rescaled with the length and mass, the optional gravity reference used in technical engineering definitions. So this provides the foot-pound second system, the inch-pound second, the British, the English, the survey foot, the FFF, which is a joke. So yeah, all these are provided, and there was never actually, so I'm the first person to fully specify a unit system for these in terms of like the Boltzmann constant and things like that. Like the SI 2019 specification, it only ever specified what do you call it, the metric system, right? So there was no, they came up with the idea that you're going to use the Boltzmann constant and all that to try to specify these things, but nobody had done a similar thing for the English units or the British units, but I did. So I came up with how to do all that. So I did it all and I came up with it. So like, for example, we look at the English system. Got the Boltzmann constant, and some of these values were all known, but I have it. It fits all into my system here, so it's all unified. So I mean, this overcame many problems that may have existed in other systems. So astronomical unit system. The International Astronomical Union units are based on the solar mass, distance from the sun to the Earth, and the length of the terrestrial day. So this constructs a new unit systems from U rescaled along time, length, mass, and dimensionless Boltzmann and molar mass constants. So some more variations include the Hubble and the cosmological quantum. They use this constructor. And then there's the natural unit systems. So these are very interesting to physicists. With introduction of the Planck mass, a set of natural atomic unit systems can be derived in terms of the gravitational coupling constant. So alpha G is this gravitational coupling constant, and this is gonna show up in a lot of these. And then the Boltzmann constant is set to 1, molar mass is set to 1, and these other constants are set to 1. So here are some ways you can do that. So you can set a bunch of these constants to 1 and then just use the gravitational coupling constant to create this Planck system. I'm not going to read out all of these, but basically physicists have been thinking about different kind of unit systems for a long time, and they can all be fitted and unified in my unified system of quantities here, and the way you define these unit systems can be expressed in this way. And the following is a new set of formulas for fundamental physics constants. So these are, as I was developing UnitSystems.jl, I had to try out formulas involving fundamental constants of physics, right, in order to check if it was consistent, to see if it actually was correct, right, if multiplying these numbers together actually was the correct thing and whatever, right? So if because these relations are going to be what's used in physics, these are the fundamental relations of physical constants that show up in physical in the equations of physics, but the problem was that when they're described in the literature in physics, they're only described in like a more limited way, not with all the 11-dimensional physics constants and dimensions that I standardized here. So because I worked really hard to standardize an 11-dimensional constants for physics, this didn't exist before. Like some of the pieces of this have existed before, but not all of it unified together in one way like this. And so this is the unification of all these formulas, basically, is from extended to 11-dimensional physics dimensions, as I described in my paper here. So like the speed of light in vacuum for massless particles, the Planck constant h, which is energy per electromagnetic frequency, the reduced Planck's constants, which is the Planck per radian, the Planck mass, which is the factor from the gravitational coupling constant, and the Gauss gravitational constant from Newton's law, the gravitational constant, the universal gravitational constant, capital G, of Newton's law. And then there's one that's from Einstein's gravitation constant of his field equations. And all of these are related to each other. The Dalton is the atomic and nuclear constant, the atomic mass unit of 1/12 of the carbon-12 atom's mass. Then we have the proton mass of a particle with a positive elementary charge, and the electron mass, which is the electron rest mass of a particle with a negative charge. And the electric potential energy EH of ground state hydrogen atom. That's the Hartree electric potential energy. And the Rydberg constant is the lowest energy photon capable of ionizing an atom at ground state. And this is the most precise known measurement. So this is very important source foundational value for the measurements. And the Bohr radius of the hydrogen atom in its ground state, and the classical Lorentz radius or Thomson scatter length is the electron radius. Then we have the hyperfine ground transition frequency of cesium-133 atom. We have the thermodynamic constants. The molar mass constant is the ratio of the molar mass and the relative mass. The Avogadro number, molar mass, Dalton atom count in 12 grams of C12. So the Avogadro number, it's obviously not exactly known how many atoms are in 12 grams of carbon-12, but we just define it as the molar mass divided by a Dalton. Basically, we can think of it like that in one sense. So that's why I have these. I mean, there's different ways you can think about it, and that's what these formulas show. And yeah. So the Boltzmann constant, that's the entropy of a unit of microstate permutation. That's another one of these interesting constants related to the Boltzmann constant, the Avogadro. So these are all fundamentally related. You can calculate it from the Rydberg constant and the fine structure constant and things like that. So this is like a nice formula for it, I think. The molar gas constant, this is very important. Ru factors the gas constant and the molar mass constant. And this is basically the product of the Boltzmann constant and the Avogadro number. The Low-Schmidt constant is the molecule count or number density of a unit volume of ideal gas. And then we have the Sackur-Tetrode constant. This is the ideal gas entropy density for PT and atomic mass M. The mechanical heat constant. It's the heat to raise one mass unit of water by one temperature unit. And this can be described as this kind of 1.9859 mechanical heat per molar amount per temperature units to define the steam table calorie. So this was actually one of the toughest things for me to define and figure out. The Sackur-Tetrode thing, that was very tough and difficult as well. I mean, a lot of these things, there was so much toughness and difficulty in unifying all the unit systems. And how can you do it? How can you express all of these things in a unified way so that it all multiplies out correctly in the correct way? Yeah, and then this one was just the mechanical heat constant. This one was a very tricky one, because it required the international unit system for the steam table conventions. So it required a very sophisticated level of understanding of the historical unit systems of the steam tables and how to transform those into modern values. And I eventually figured it all out, and these formulas are my kind of reference equations for understanding what I did there. The Stefan Boltzmann unit, sigma of the black body radiation, this constant that you can express it like this in terms of the Rydberg constant. Radiation density of the black body radiation, that's another one of these thermodynamic constants. Wien wavelength displacement law based on the Lambert W0 evaluation. So people don't, this isn't something that you need to evaluate. I mean, it's nice to have this as a constant, so that's why it's included as a fundamental constant instead of relying on evaluating this function. You can rely on this fundamental constant. Similar with the Wien frequency, which was the radiation law based also on the Lambert W0 evaluation. The luminous efficacy of the monochromatic radiation KCD at 540 terahertz. This definition is kind of in terms of an integral. So this is kind of an interesting definition that's a little bit different. The rationalization constant of magnetization and polarization density. This is important for the important relation for the unit system definition. And the Lorentz constant, electromagnetic proportionality for Lorenz's law of force. The electromagnetic proportionality constant, yeah. Sorry, I was drinking a sip of water. The Biot-Savart constant, magnetostatic proportion for Biot-Savart's law. Vacuum permeability, magnetic permeability of the vacuum. There's different ways you can express that in terms of different constants. Vacuum permittivity, the dielectric permittivity of a vacuum. Vacuum impedance ratio of the electromagnetic field. Electrostatic scalar for Coulomb's law of force. Magnetic proportion for Ampere's law of force. Quantized elementary charge of proton-electron. Faraday charge per electron mole based on elementary charge. Quantized electric conductance unit, conductance quantum. Klitzing, the quantized Hall resistance. Josephson constant, potential difference to a radiation frequency. The magnetic flux quantum. And the magneton, Bohr's electron magnetic moment unit. So I wrote down many of these formulas, extended them. So there was no single reference source that extended and unified them with the unified system of quantities until I pulled together all of these into one single place and tied them all together in this particular way here. So I'm very satisfied with how it turned out for studying for reference purposes. Like I like to reference this. It's great referencing. Yeah, it's a reference material. So then we have the dimensionless coupling constants, physical measurements, measure dimensionless coupling values with uncertainty. So those were the electron to proton mass ratio, the proton to atomic mass ratio, the proton to electron mass ratio, the inverted fine structure constant, and the gravitational coupling constant. So these just an example of evaluating those. And there were many astronomical constants that I included as well. The Eddington number of protons in the universe, solar mass estimated from the gravitational estimates, the Jupiter mass estimated from the gravitational constant estimates, the Earth mass estimated from the gravitational constant estimates, the lunar mass estimated from the Earth-Moon mass ratio, gravitational force used in technical engineering units, the Earth radius, which is the approximate length unit of the standard Earth two-body radius. The great circles, the approximate length unit of the standard Earth two-body circle. Then we have the Gaussian month, which is the orbit time of the lunar distance. So you can see yeah, 27.45 days. Sidereal month, 27.28 days, so a little bit different. And then you have the synodic month, which is the one that we're more familiar with. That's 29.5 days about. This is the kind of exact approximation. And you can see, yeah. So we have the Gaussian year, the orbit time from the Gauss gravitational constant for negligible mass satellite, and the orbit time from the Gauss gravitation constant and the Earth moon mass. And then we have the Jovian year, which is the orbit time defined by the Jupiter distance and the Sun Jupiter system mass. And the radar mile, that's the unit of time delay for a two-way nautical mile radar return. And then there's the Hubble constant and the cosmological constant for the universe expansion frequency parameter and the constant from Einstein's controversial theory expanded on by Hubble. So many different kinds of constants included here that you can immediately have accessible using my system, using my definitions. All right, so the 11-dimensional operators that are necessary for standardizing the unified system of quantities have never been discussed or researched until the UnitSystems.jl project specified them to completely unify all historical unit systems. The only person who can be fully credited for the discovery of these new 11-dimensional operators for the unified system of quantities is Michael Reed, the researcher who was the first in history to investigate these operators to unify all historical unit systems to standardize the specification. So this was a result of me deciding to create the UnitSystems.jl project and following through with it, because I chose to start the project and I continued it and I followed through with it, and that's why I'm the person who came up with this, right? So that's why that I'm the person who's credited for it, basically, right? So discovering the fact that 11 dimensions are necessary and what the actual representation of the operators are is an extremely difficult task requiring extensive knowledge of all the historical unit systems specified in UnitSystems.jl. Since the discovery has been made, any future application of these 11-dimensional operators is an application of Michael Reed's Unified System of Quantities. Not only are the new 11-dimensional operators necessary for complete unification, it's also necessary to extend the fundamental formulas involving the fundamental constants of physics, which has been presented in terms of an 11-dimensional physics system as part of this project for the first time in history. This includes relations necessary for Maxwell's equations, chemistry, and thermodynamics based on the new 11-dimensional physics system. So what this means is that if you're using these fundamental physics relations that are described in this paper, you're using my 11-dimensional system because the formulas involve 11 fundamental constants as building blocks, and it's not like the system from that they had in the past, which was based on 7 or whatever constants that they had in the SI 2019 system, or other unit systems that were defined in other historical times. They were all limited. None of them were unified, that included everything. that has been historically done. Nobody has ever unified them all into one thing, right? So in order to unify them all, the 11 dimensions were necessary, and that's why. And I figured that out from going back into history and looking at all these historical definitions and figuring out how they overlapped each other in such a what the overlap is between the historical unit systems. And from that I could infer, I filled in all the information basically. So it's like, imagine the process of going back into history and trying to extend this information, fill it in a way that unifies it. Anyway, let U be a unit system with its corresponding 11-dimensional physics operator representation rho. Two units, A and B, are equivalent physics dimensions in U, a unit system, if and only if U of A equals U of B, when U is applied on A and B as an 11-dimensional physics operator and representation rho of U has a null space. This leads to the creation of an equivalence relation on U, which can be denoted with like an equivalence relation A sim B, forming the equivalence classes like that. The U slash sim, basically, that's the notation that's used for equivalence classes. In the package similitude.jl, it's actually like an actual computer programming syntax that I implemented. So the equivalence classes are computed that way. So the Maxwell unit and is an equivalent to charge, electric flux, and the magnetic flux or the pole strength. So if you pick the Gauss system, charge, electric flux, and magnetic flux and pole strength are all the same unit, which is a Maxwell. So there's basically this equivalence class of dimensions in the original Gauss unit system, and in that equivalence class, you could find charge, electric flux, magnetic flux, and pole strength, for example. This is just an example. It could include more things as well, but those are like some of the standard ones. But in modern times, we have the metric system, and in the metric system, charge, electric flux, and magnetic flux, and pole strength are all different quantities. Like charge is Q and electric flux is this here. So they're not the same anymore. Here they were all the same, and here they're not the same. Now this is what makes things difficult. This is why nobody solved this problem until I tackled it like this with 11 dimensions, because the question was, well, what's going on there? Like, because you have this degeneracy, basically. You can think of it as degeneracy, that there's a null space. There's this 11-dimensional operator representation which has a null space, and because of that null space being a dimension greater than 0, that means that there's going to be non-trivial equivalence classes compared to what's expressible in the 11 dimensions. So the most complete understanding that I've derived from unifying all historical unit systems requires 11 dimensions, but the Gauss system, the specific system, like the metric system or the the Gauss system, they were not 11 dimensional. It's only the unification which is 11 dimensional, right? But the individual ones in the past, they had less dimensions than that. And so the null space of the operator is related to that dimension, in fact. So the 7 dimensions and the 4 dimensions. So we have we'll get into that in a moment. So let's try out these equivalence classes, Gauss and metric. So in the Gauss system, we can see, what were some equivalent quantities in the Gauss system. It produces a list of these equivalence classes. Anyway, in particular, the reason why it is mathematically impossible to create a mathematically consistent unit system with only 7 physics dimensions, as in the SI 2019 standard, is because these 7 dimensions are only a subspace of the full 11 dimensions necessary. So the impossibility problem comes from the fact that there is a 4-dimensional null space in operator representation for this metric system. To work around this core issue, in the UnitSystem standard with Michael Reed's Unified System of Quantities, the core problem is solved by always relying on an underlying 11-dimensional physics representation, which has enough dimensions to characterize the relative null space of all historical unit systems. Figuring out this 11-dimensional physics space requires research and development to discover the fundamental relations which maintain the correct physics constants under all historical unit systems. This problem was entirely solved and documented in public for the first time in history by Michael Reed in this project. So basically, there's all these different historical unit systems, and in order to make them consistent with each other, or in order to make them expressible in a unified way, 11 dimensions were necessary, but any particular unit system, like the metric unit system, it only had 7 dimensions. And so there's this 4-dimensional null space, and that creates equivalence classes in the unit system choices. The 11-dimensional operator corresponding to the unified system is an isomorphism of any unit system with the Unified System of Quantities, USQ. So what this means is basically here's an isomorphism linear operator, 11-dimensional, which relates the unified system of quantities with the unit system definition. So the unified system of quantities was what I proposed earlier as an extension of the international system of quantities. So the international system of quantities was limited, didn't have enough quantities in it. And so this 11-dimensional system has force, mass, length, time, charge, temperature, molar amount, luminous energy, angle, the rationalization constant, and this non-standard dimension. So all these different extra dimensions, there were some extra dimensions that had to be included in order to basically deal with this. And these are the fundamental constants that I chose as unit system constants. So those were the Boltzmann constant, the Planck reduced constant, the speed of light, the vacuum permeability, the electron mass, the molar mass, the luminous efficacy, the angle, the rationalization, the Lorentz constant, and the gravity force. So those are 11 fundamental constants that get chosen to define a unit system. And these are the 11 fundamental dimensions that we actually use to express dimensions like charge and so on, right? So we want to use these kind of so there's these two different ways of doing it. So the unit system is actually and there's this is just these are isomorphic to each other. It's just a linear transformation to go from this to that. Okay, that's why it's an isomorphism. So what this isomorphism means is that it's the isomorphism of any unit system with the unified system of quantities. So I proposed what a unified system of quantities should be, and that this is what it should be. And then I defined what a unit system should be, and this is what it should be. And then this is the isomorphism between them. So yeah, I defined all aspects of this. That was all defined by me, like the idea to make this 11-dimensional and how to express it, like which dimensions to put there and which fundamental constants to choose and so on. This was my design, right? So I designed this operator choice, and there was actually no one had ever chosen something like this before. I'm the first person to make a choice about this, right? So but I standardized this already, so this is already the standard already now in my system. Any other project relying on these 11-dimensional fundamental constants of physics from the Unified System of Quantities is then essentially referencing Michael Reed's work, or in the case of Wolfram Research, they are doing plagiarism as explained in the timeline in the preface. So I essentially handed Wolfram Research my unit system standard, right? Or they were studying my unit system standard and implemented it. They took my standard and fully adopted it. This is what I'm saying. So well, you can see that in their when you take a look at what it is, it's basically my standard that they adopted, and you can and you can basically figure out that it's my standard from taking a look at it and looking and seeing how it's my formalism that's being that it is. So the formalism that I standardized here. So here so here's the representation for the metric system, and there's an engineering one which has radians and kilogram force. So this has newtons and kilograms. This has kilogram force and kilograms. And this has kilogram force and Hill or Heil or Hill. No, it's Hill, I think. I don't really know how to pronounce this because I've not heard it pronounced before, but this is a type of unit of mass related to the kilogram force. Yeah, so that's for the gravitational system. And there's an operator for that, and for the Gauss system, there's an operator for that. We have the Maxwell unit here, the dyne, the gram, the centimeter, and the EMU and the ESU system. Then we have ones like the Planck and the Planck-Gauss system. This one is with the Planck mass and the charge, natural charge. And then we have this null operator for the natural unit system. So the natural unit system is actually just a null operator. So all zeros. It's got the full null space. And if you look at the equivalence classes, natural, how many? It's a one element, because everything is in the same equivalence class, because it's the complete null operator. If you research the formalism that I've provided here, you'll understand the significance of that. The natural Gauss system is another one of these. Then we have the Hartree system with the Bohr radius, and the elementary charge, and the QCD original, Rydberg, Stoney, electronic, metric degree. That's like the metric one, but including the degree unit instead of radians. So all these things have these 11-dimensional operators that help formalize these things, and that was all formalized by my project. So that wasn't formalized with this 11-dimensional unified system of quantities with the unit system isomorphism. That's all my idea. Michael Reed's contribution to mathematical physics can be recognized as this new 11-dimensional operator formalism, enabling complete unification of all historical unit systems with the unified system of quantities. In particular, the equivalence classes of physics dimensions in any historical unit system are now fully characterized by the null space of the 11-dimensional physics operator representation, as it was systematically researched and documented by this project, accessible with this syntax. In particular, the dimensionless physics dimensions in any historical unit systems are the null space of such an operator representation. These group elements are considered dimensionless when operator representation is applied, but the underlying representation is an 11-dimensional vector space which enables the unification of all historical unit systems. The source of the problem is that these operators are not isomorphisms, which means that the null space is an unavoidable aspect to solve the problem. The only way to work around this problem is to use this new formalism based on 11-dimensional physics pioneered by Michael Reed's system. This means that the natural unit system appears to users to work with all dimensionless quantities, but here it uses a new underlying 11-dimensional vector space to enable unit conversion to any other historical unit system. This problem is mathematically impossible to solve by formalism of 7-dimensional physics unit system standardized with the SI 2019. Only with Michael Reed's new contribution has this problem been solved completely. One of the new unit systems created by Michael Reed is the modern ideal meridian system defined by France's original Earth meter definition. So I also created a meridian system which has like the actual meridian meter, which is 100.144 centimeters. And so that's, if you actually try to estimate what the actual meter should be, like if there were 40,000 meters in a great circle, then that would be 100.144 centimeters. So it's a little bit more than a little bit bigger. Just like a Yeah. And yeah, so then there's the meridian gram. This is how much a gram would be if the Earth meter was used to define a gram as a volume of water, right? So the weight of that would be 1.004 grams. So it would be slightly heavier. And similar with the Earth calorie, this would be the calorie that you get as a meridian calorie. And if you convert it to the metric system, um, a meridian or Earth calorie in the metric system is 4.20 joules. And yeah, so I don't know. You can get a meridian unit of charge, an Earth coulomb as well. I standardized that just to see what the coulomb would have been if we kept it all consistent with what historians or what people in history originally kind of were talking about. Like ideally, what the ideal coulomb would be 1.0028. You know, it would be a bit big, significantly off from what we currently have as a coulomb. But yeah, it's interesting. I don't know what to do with that. I don't know. I just thought it's interesting that I can discover these idealized ones. And then there's the nautical mile, the standard nautical mile defined by the Earth radius. So this would be like the exact like nautical mile that is consistent with the Earth radius, that standardized, basically the standardized one, basically, right? The most modern, the most up to date modern standardization of it, not like the one from like textbooks a few years ago or whatever. The most modern one. And then yeah, then we have all these tables. So yeah, like 700 pages of tables. The first few tables are the fundamental tables that initialize, that explain the initialization. Like these are the fundamental constants that are the building blocks, fundamental definitions, fundamental. This is all what I think would, what I consider standardized, or what I want it to be. This is what I wanted to standardize all in one thing with my system, basically. So all these things are standardized in one system here. All these different kinds of horsepower. And then there's these kind of tables like unit of force. Could be the Newton, the pound force, or the dyne. Then we have these EMUs and ESUs and the metrics and the coulombs and so on, and henries and volts, and all this is tabulated. So I generated all these tables with my unit system, unified system. This all I standardized all these things so that these tables can be created, and all this is the programming. I programmed it, you know what I mean? So and then we have all the data. So yes, I'm not gonna. I'll let you check out the data. I mean, the purpose for making this into a PDF document is just if there's a specific table that you want to print out, this single PDF document contains all the, well, a huge amount of tables that you might want to print out from my website. So my website contains all this information as well. Contains all these tables. And if you're interested in particular ones of these tables, printing them out, this PDF document, you can find the table there in a format that's better for printing. Obviously, you don't want to print out all 700 pages. That's not what this is about. But this is just about the beginning, printing the first few pages maybe that explains the reference, and then the tables. You can select which tables you're interested in. Yeah. So yeah, this is my project. Seems like Wolfram Research. Well, I mean, if you look at the timeline, I started this independently before encountering Wolfram Research. Then they were very interested in it and wanted me to present it to them. So I already had this complete, and so I presented it to them. And if they wanted to, we could have gotten started on bringing this into their software stack for using my design right then and there. But they told me they don't want me to work on it, and then after after 6 months of working there, they ended my contract. And now in 2025, Wolfram seems to be like using this unified system of quantities that I created. It seems to be signature of it is what's they are now using in their systems and promoting in their social media campaigns and so on, but they don't seem to acknowledge that this is my creation. I'm the inventor of the unified system of quantities, and I handed this to them. It's a standard that I created on my website that I standardize it and allowed Wolfram to have it by presenting it to them, and they were able to take it, I guess. But it's really weird. They how they're like stalking me, gang stalking me basically, but they don't want to like. When I was there and presented it to them, they never wanted to acknowledge that it was a great idea. Like now it seems to be built into their system, and they want to like have a social media campaign about it and whatever, and want to pretend. But this is my standard that they're promoting now, so they're basically making my standard even more standard. So like this wasn't standard before I made it standard, like before I standardized it into a standard thing, right? And then now them adopting it standardizes it further, right? So this is just standardizing my standardization, right? So that's what it is. But are they gonna acknowledge that? Are they gonna say, is Wolfram gonna come out and say, Yes, Michael Reed standardized this unified system of quantities, and we're now standardizing his standardization as the standard. Is that what's going on, or I don't know? I don't know. Why don't they talk to me about it? You know, the it's just really they're a bunch of weirdos. They don't they I don't know. This is the story about it from what happened, from how I created UnitSystems.jl, and I solved the problem, and yeah. So I don't know what else to say at the moment. This is my my video about it for now. So yeah, it's UnitSystems.jl, the Unified System of Quantities.